So sorry about that. It's so hard to find good help these days. Oh no. 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 Oh, alright. Anyway, you're here to see me, Daniel, Grand Vizier of the Switch and Lever Knights, turn an old and forgotten Guitar Hero guitar into a new and exciting MIDI instrument through Arduino. So, let's hit it! Are we done here? So, just to quickly recap, this is a bit of a culmination of two previous videos. One where I circuit bend a kid's toy keyboard into a new and god-awful instrument, and another where I build an Arduino MIDI controller. In this video we'll meld those two videos, much like how Jeff Goldblum got more awesome with the help of an innocent housefly, and through some new techniques come out with an actual playable MIDI guitar. Kind of. To follow along, make sure you secure your parents' or significant other's permission first. Second, we're going to need some stuff. Obviously, we're going to need an Arduino, and I'll speak more about which kind a little bit later. You'll need a female USB Type-B connector. I ripped this one out of an old printer. You'll need a micro USB cable, a proto board and some wire, along with some random bits and bobs we'll add on through the project. Of course, you're going to need some tools as well, like a good assortment of pliers, cutters, and just good all-around tools to break into and modify the guitar. What better pliers could you ask for than these old and basically indestructible Swedish Lindström pliers? Though they are a bit outdated. I wonder if we call them up if they could help a social media influencer out. Hi, this is... Yeah, I got some old... Yeah, so all I have to do is... Oh, that's great. Thank you so much. Full disclosure, I did reach out to Lindström, who were more than happy to sponsor this video. I've been using their pliers, both vintage ones like the ones you just saw, and these new style ones for many years in both a hobby and a professional capacity. And as far as electronic pliers and cutters go, they are simply unbeatable. But hang around if you want to know more once we get stuck far deeper into the project. Beyond pliers, we're going to need a glue gun, a soldering iron, a multimeter, and an assortment of miscellaneous screwdrivers and other good to have around tools. And maybe most importantly of all, we're going to need a Guitar Hero guitar. These guitars are basically trashed these days anyway, so save one from a landfill if you have to. I found mine from a flea market for just a couple of bucks. This one is a Nintendo Wii variant, which is why it has a big hole for the Wiimote, but any Guitar Hero guitar should be similar enough for you to follow along this project reasonably well. So before we start digging into this thing, let's touch briefly on what we're actually going to do here. The Guitar Hero guitar is essentially an input device. It's full of buttons and controls which are read and processed and sent through a controller to a game console. These are standard inputs though, they're buttons and potentiometers, and there's nothing that says that we cannot simply cut some wires and read these inputs ourselves, in this case with an Arduino. Those who watched my last MIDI video may remember that I used a regular Arduino Mega and then had to use a couple of different programs on the computer to handle the processing and conversion to MIDI. That's of course fine and dandy, but wouldn't it be nice if we could step it up a bit and make it a little bit easier? Luckily we can. As you probably know, there are lots of different Arduino boards out there with different microcontrollers, which in turn have different abilities. the regular Atmega 328 microcontroller, which is common on the Arduino Uno, or the Atmega 2560 as we find on the Mega, doesn't really make it easy to emulate other hardware. However, there are Arduino boards with the Atmega 32U4 microcontroller, which on the other hand can be programmed to act as various input devices, such as keyboards, mice, or even, yes, a MIDI input device. There are a few different Arduino boards using this microcontroller, but for this project we will use the Arduino Pro Micro, which is both super cheap, small and readily available, which makes it perfect for integrated solutions. You may have seen a previous project where I used one to make an egg carton gamepad, so they really are very versatile. Of course, if we're going to be able to get that far, we have to get into the guitar. So start by taking the neck off by unlocking it and pulling it straight out. Sell that on GuitarBay? No, wait, we need it. Unlock and remove the faceplate and start undoing the screws. Once inside, all your hard work will be rewarded. Once all the screws are out, we can start looking at how this hack is actually going to work. Flip it over and take off the back, and we immediately notice a few circuit boards inside. We can see the neck connection to which we will tap into to be able to read the buttons of the neck of the guitar. The main circuit board in the middle, to which everything connects, will be entirely disconnected and only used to read the two switches of the strum bar. The connectors for both the joystick at the bottom and the whammy bar are essentially just potentiometers, which are also no problem to read with the Arduino. Altogether, we only have 9 buttons to read, as well as 3 potentiometers, so this will be easy peasy. I'm bored, there's just not enough action so far, so let's start snipping random wires and hope for the best in the end. I'm sure I won't regret this. A hero, this guitar will be no more. Now may be a good moment to actually talk a little bit about these snazzy new cutters I'm using. As I touched upon before, they're from a Swedish brand called Lindström, who has been around since 1856 and quite literally set the standard for early hand tools in Sweden. As some of you know, I collect and I use all sorts of tools, and I have amassed quite a few old Lindström pliers through the years. And while they will definitely still remain in service, I am more than happy to add these to my repertoire as well, for more delicate electrical work. Since they're fully ESD safe and with an ergonomic grip, these are ideal for a wide variety of uses. I know they're used avidly by jewelry designers, as well as in the medtech and aerospace industries. As you may know, I do not endorse things on this channel unless I truly believe in them, and Lindström is 100% a brand I can get behind. Now let's get back to our "Hey, where did this come from?" Well, I guess you can't talk about electronic pliers without talking about electronics. And if you're designing your own electronics, you probably have already looked into custom circuit boards. PCBWay has been in the market of custom-made circuit boards for over 6 years now. Starting out at just $5 for 10 boards, you really cannot go wrong, no matter if you're just making a few prototypes or if you're setting up entire production runs. Regardless if you just need a bare board or fully populated and finished boards, they got you covered. head on over to PCBWay.com and check them out. Alright, now can we continue? Amazing. Maybe we got a bit cutting crazy there. Was it all a mistake to cut all those wires? Nonsense, I say. It actually makes it easier to figure out which wire corresponds to which button and to which potentiometer. Basically what we need to do is to take our trusty multimeter, set it to continuity mode and hook it up to 2 random wires on each module and push the buttons in that module to see what it does. If it beeps, you know you made a connection and that those 2 wires are connected to the same button. If you find a wire that's connected to more than one button, that is the ground wire, which is common among all buttons in that module. What I do to make my work easier in the future is to mark the wires with the corresponding colors. Here I've chosen black for ground and blue for the signal wire. Moving on, you can do the exact same thing with the buttons on the neck. Reconnect the neck and methodically test every wire against the others as you're pushing the buttons. Once you find a wire that all buttons work on, that's the ground wire, and you can easily mark out the others accordingly. At this point, don't worry about which exact wire goes to which exact button, it will all make sense in a bit. As for the joystick, they've actually made our life very easy for us by labeling ground, voltage, and the X and Y axis directly on the circuit board. All you need to do is follow the trace to the corresponding wire. Here again, I've marked ground with black, but since the potentiometers in the joystick also needs power, I've marked those with red and the 2 analog signal wires with green. The whammy bar potentiometer doesn't really need any measuring. Most common potentiometers share the concept of applying power and ground to either side, with the wiper being the middle pin, so mark accordingly. Last thing we need to worry about are the 2 switches under the strum bar, but again it couldn't be easier. It's just 2 micro switches, one for strumming up and one for strumming down, and they only need to be connected to ground and each to a digital pin. So they're marked black and blue accordingly. Now you may be confused how I haven't labeled these. How do I actually know which wire corresponds exactly to which button or to which axis on the joystick? Won't it make things more difficult later? I promise that I will cover exactly this in a little bit, but first of all let's solder us up some Arduino and hook all these wires up to their corresponding pins. As you may have noticed, I didn't so much put thought into which pin I connected which wire to, aside from making sure that the analog pins go to analog and ground to ground. But as far as pin numbers go, I left it entirely arbitrary. This is simply because it's a very easy thing to backtrace, even once a device has already been built. I wrote a simple pin testing program which will simply read all the pins on the Arduino and output the results to the serial monitor. Simply load it onto the Arduino and start pushing buttons and make note of which button corresponds to which pin. You can later use these pinouts in whichever Arduino sketch you decide to program this with. However, we have a very specific purpose with this guitar: to make it speak MIDI. As mentioned before in my previous video, I used 2 different softwares on the computer to make the Arduino properly speak MIDI. With the Arduino Pro Micro, that's no longer required, as you can use it to emulate a native USB MIDI device. This is done through a library called MIDI USB. Looking at the code, we start by defining all the pins with the pin numbers we got from the previous step, and we assign values to hold their states.
The sketch is continuously reading the pins on the statue.
Okay, hold up. There are few more boring things to do in a video than to talk and to dissect code. This would simply take forever to go through step by step. Basically, the short of it is that the sketch reads the buttons and outputs the button presses as MIDI values corresponding to certain notes. The joystick works vertically as a pitch bend value and horizontally as the mod wheel on a regular MIDI keyboard. The whammy bar is also used to pitch bend similar to the joystick, but only to increase the pitch. The buttons on the bridge transposes the notes up or down an octave per button press. If you want an in-depth look at the code, there are links in the description to the Switch and Lever GitHub page, where both the pin tester sketch and the MIDI Hero sketches can be found. And with that, that's basically it. The guitar is done. Is it though? Really? Is it though? Now it is. Besides the amazing new paint job, if you paid attention before, you may have noticed loose wires to prepare for 2 more little upgrades. In the space where the Wiimote was supposed to fit, there are now LEDs which light up, as well as a switch which toggles between single note mode and chord mode. When the switch is pressed, it will play single notes from the buttons on the neck. But when the switch is not pressed, it will only play chords. This is done by holding down one of the neck buttons and strumming the strum bar either up or down. There's a tiny delay in between to simulate the individual strings of the chord being strummed, and it's different depending on if you strum up or if you strum down. I'm using the excellent and free Ample Guitar M2 Lite VST from Ample Sound to receive the MIDI. You can of course use whichever VST or DAW you want for your project. It doesn't even have to be a guitar. The code for this has all been very carefully commented, but make sure that you like, subscribe and to comment if you have any questions whatsoever. Now let's take this thing for a spin and see how it works out. So, I never said I could play it especially well, but it is fun to play. Despite the anticlimactic ending, I hope you enjoyed this video and that it gave you some ideas of things you could do yourself. So make sure that you like, comment, subscribe, follow on Instagram, hydrate, stand up for what's right in the world, and just absolutely click and watch another switch and lever video. Until next time!